Example 1. To understand the concept of movement methods, we take a simple example. Let x1, x2 up to xn be the random sample from the normal population with mean mu and variance sigma square. Find the moment estimators of mu and sigma square. So we have to find the moment estimator of mu and sigma square. This example is taken from the Cosella and Burgess book. So how we proceed? First of all, we must know the probability density function of the normal distribution, which is 1 over under root 2 pi sigma exponential minus 1 by 2 into x minus mu over sigma whole square, and we know that it is from minus infinity to plus infinity. The first and the second moment about origin, we can find it as that is mu 1 dash, that is the population moment, which is the expected value of x, as I have already shown in the previous slide, and that is equal to mu. That is well defined. Again, we can find the second moment, that is the expected value of x square, that is equal to from minus infinity to plus infinity, that is x square f of x dx, और ये भी well defined है, that is mu square plus sigma square. Since there are two parameters, so obviously we need two equations to find the moment estimators. So now we are going to equate it by the sample moments. Sample moment is denoted by m1 dash, and that is equal to mu 1 dash, and the second sample moment is denoted by m2 dash, that is equal to mu 2 dash, and which is mu 2 plus sigma square. The moment estimator for mu is now, that is mu hat, which is m1 dash, and that is actually the mean of the random variable x. So that is equal to x bar. Similarly, for the sigma square, that is equal to sigma square, and that is equal to m2 dash minus mu 2 square. We just equate it from here, from this equation. So putting their respective values, that is actually 1 over n sum xi square minus x bar square, and this can be written as that is 1 over n sum xi minus x bar whole square. So for this example, the moment estimator are the same as the MLE estimators. So the two moment estimators are this one, that is the first one, which is the mean, and that is the second one.